Okay, next story problem set. A student sells small and large greeting cards. The small cards cost $3, the large cards cost $5. The student sells 25 cards. They make a total of $95. How many of each type of card were sold? You get to have 3 units, so we go to that table. Now give yourself some room below the table. You're going to need it on these. You'll see why when we do the table. So I've got together, how many per, so dollars, so per in total. Then we got small, large, and money. So small and large would be the 2 products we have, and then money would be the per and the total. Now together you're paying $95, nothing new there. But now it changes. Give me a number that is not related to the cost, okay? Not that, not that. Those are money amounts. We do not put those up here. If they have dollar labels, they do not belong in the top row. Well, the only thing I see is 25, but it doesn't say it that small and large. So 25 is how many they bought together. And when you note the together amount, but you're missing how many separate, you got to use X and Y, okay? You are still going to black this out. The 25's gone. Now, we actually have our cost per. How much do the smalls cost? They cost $3 and $5. So, X times 3 is 3X, Y times 5 is 5Y, so that's the equation. But I need another equation to go with it because there's an X and a Y, and that comes from up here. So I make a cross, okay? Kind of like the 4 boxes. On top part I write X plus Y equals 25. And then the bottom one I write 3X plus 5Y equals 95. Now when you have this, you always want to use the elimination method, okay? You could use substitution, but it takes more work than necessary, okay? So that's when I try to add to get to 0. But 1x plus 3x wouldn't be 0, and 1y plus 5y wouldn't be 0. Okay, that doesn't work, so check the numbers in front. Are these the same? Nope. Are these the same? Nope. So look at your x's. You have a 3 here, so we're going to times by 3 here, and you have a 1 here, so we times by 1 here. So I also have to times the rest of this equation by 3 to keep it balanced, and this by 1 to keep it balanced. So now I have 1x times 3, which is 3x, 1y times 3 is 3y, and 25 times 3 is 75. Now the bottom, you're going to have 3x, 5y times 1 is 5y, and 95 times 1 is 95. Okay, now set up your elimination again. Well, that's 6x and that's 8y, so that won't work, but we have the same number now, so if I make that negative, that'll add to 0. But then we got to make the 5 and the 95 negative. So 3 plus negative 5 is negative 2y, and 75 plus negative 95 is negative 20. Then I divide by negative 2, and y is equal to 10, okay? Now go to where your y is at, and you have 10, so you have 10 large, okay? Now to get your small, you can either just take 25 minus 10, and that would be the x, or you can use this equation here, 1x plus 1y equals 25, and we replace the y with 10, okay? So 1 times 10 is 10. The y is now gone, okay, plus 1x. So I got to get my 10 to a 0 by subtracting. That's 15. And you can divide by 1 or just drop it. It's 15, okay? Like I said, you could just take 25 minus 10 too. Get it quicker. Okay, my next one. You buy apples and oranges. The apples cost $2 per pound, while oranges cost $2.25 per pound. You bought 25 pounds of fruit. The total cost is $52.25. How many pounds of apples, how many pounds of oranges did you buy? Again, 3 units. Apples, oranges, dollars. So you have together, and you have apples, oranges, and then how many per and total. Kind of jump the gun on the apples and oranges. They go here because those are the two things you're buying. And then dollars per, dollars total, but dollars has nothing to do with the top. Okay, so your total cost is $52.25. Okay, now look for non-money numbers. That's a money number. It does not belong on top. Neither does that one. How about this one? Yeah, it's got to be on top. But it doesn't say if that's apples and oranges. It just says 25 pounds of fruit. So assume that that's together, and you don't know the separate amounts. That's what we're trying to figure out here. So then we got to know what they cost. So the apples are $2 per pound, and the oranges are 2.25 per pound. So multiply x by 2, you have 2x. Y times 225 is 225y. So you have an xy equation here, and you got another one up here. So on top, we have x plus y equals 25. And on bottom, you have 2x plus 2.25y equals 52.25. Use the elimination, okay? So add. That's 3x, that's 3.25. That's not going to work, and these are not the same, neither are these, so we need to multiply. So I multiply 2, 2, and 2, and then 1, 1, and 1. So 1x times 2 is 2x, 1y times 2 is 2y, 25 times 2 is 50. Then the bottom you have 2x, 2.25 times 1 is 2.25y, 52.25 times 1 is 52.25. Now set up the adding again. Now that's 4x, but at least now we have the same number, so if I go negative, they will now add to 0, but then I got to make that negative and that negative. So I add 2 plus negative 2.25. You need to put that entire decimal, negative 0.25y. Then I take 50 and add negative 52.25, and that's negative 2.25. And when I divide, I got to divide by the whole decimal, negative 0.25. And when I divide those two amounts, I get 9, okay? So the y here is 9, so 9 oranges. Again, to get the apples, you can just take 25 minus 9, or you can use this, okay? 1x plus 1y equals 25. I already have my answer for y. So it's 9. 1 times 9 is 9, so you got equals 25. 1 times 9 is 9 plus 1x, okay? So get your 9 to a 0 by minusing, that's 16. Divide by 1, and you're at 16 still. Like I said, 25 minus 9 would have given me 16. Okay, at a football game, student tickets cost $3 each, adult tickets cost $5 each. The school sold 700 tickets. They made a total of $3,078. How many adult tickets, how many student tickets were sold? 3 units again. So when I'm using algebra in a story problem with 3 significant units, we go with this. So together, how many per and total. So I got students and adults, or you can put adults and students, doesn't matter, and you got your dollars. So what's your money total? $3,078. Okay, find me the only number in there not related to money. 700 tickets, but it's not students or adults. And it doesn't say more than either, okay? So I need to put, that's how many together. And when I have the together, but I'm missing the separates, I got to go X, Y. Okay, now students, cost per student is $3. Cost for adults, $5. So x times 3 is 3x, y times 5 is 5y. So I got this equation, but I need another one because it has 2 different letters. So I find another place in the table where it has those letters, and that's my other equation. So x plus y equals 700. The two unknowns add up to 700. Also, if you take one of the unknowns times 3 plus the other unknown times 5, I know that's a total of 3,078. Okay, elimination. That's 4x, that's 6y, not going to work. These are not the same, those are not the same, so I go to the multiplication method. So there's a 3, there's a 1, okay? So 1x times 3 is 3x. 1y times 3 is 3y, and 700 times 3 is 2,100. It's just 21 with 2 zeros added. Bottom stays the same, because you're just multiplying it by 1. Now, these are the same number, but they're both positive, so making it a negative will ensure that those add to 0, but then the rest of that equation has to go to its opposite. 3 plus negative 5 is negative 2y. Then I take 2100 plus negative 3078, that's negative 978. Divide by negative 2. And negative 978 divided by negative 2 is 489. So the y is 489. Okay. So you can put 489 in for the y here, or you can just take 700 minus 489. I'm going to take 700 minus 489 to save some time. 211. Okay. You could also plug the 489 in for y like I did on the first two. You get the same thing. Okay, last one. A farmer's market is selling apples for $1.99 per pound, oranges for $1.50 per pound. You buy 12 pounds of fruit. You spend a total of $21.92. How many pounds of apples, how many pounds of oranges did you buy? 3 units once again. Okay. So we have together. How many per and total. So you got apples and oranges, and then the money. So your money total is $21.92, $21.92. Okay, give me some non-money number. The only one you have is 12. So you buy 12 pounds of fruit. So that's what you bought together. So that's X, that's Y. We don't have the separate amounts. Get rid of that. Okay, how much do apples cost per? $1.99. The oranges are $1.50, so we can write X times $1.99, $1.99X, $1.50Y. So I have a system here and here. So I've got X plus Y equals 12, and then 1.99X plus 1.50Y equals 21.92. We're using the big E, the elimination. That isn't 0, that isn't 0. Those aren't the same, those aren't the same, so multiply. So I got 199 here. And I got 1 here, so times 1. So I times the rest of this by 99 on top, the rest of it by 1 on the bottom. Okay, so 1x times $1.99, $1.99x. 1y times $1.99, $1.99y. And then 12 times $1.99, 1.99, 23.88. And the bottom stays the same because you're just multiplying by 1. 1.99x plus 1.50y equals 21.92. Now here I got the same number, but we got to make them the opposite so that they add to 0. So making it negative means that those add to 0. But then I got to make the rest of the equation opposite. So I take 1.99 plus negative 1.50, 0.49y. Put the whole decimal. 23.88 plus negative 21.92, I got 1.96. Now remember, when you divide, we got to divide by the entire decimal, 0.49. Divide that stuff, and I come up with 4. So that y is 4, so 4 pounds of oranges. Now, remember, together, you know there's 12, so 4 pounds of oranges. Yeah, you can put the 4 in there, but I can tell you, you're just going to be 12 minus 4 is 8, okay?